the different shapes. So it says right here, for any rhombus JKLM, decide whether the statement is always or sometimes true, draw a diagram and explain your reasoning. So rhombus JKLM, I'm just drawing it right here. So this would be rhombus JKLM. And for this rhombus, so in a rhombus, all these sides are the same length. So that's going to be helpful for us to know. And then also the diagonals right here, we're drawing those. The diagonals make a 90-degree angle. We'll just stick with that for now. There are more characteristics of this because remember, rhombus. Rhombus also follows all the characteristics of a parallelogram and a quadrilateral. And then squares are rhombuses too, so we have to consider that. Okay, so it says, is L congruent to M? So is angle L right here congruent to angle M? Well, no, not necessarily. Unless it's a square, then L and M would be congruent. So the answer is sometimes when the rhombus is a square. Sorry. Okay, and then the next one, K congruent to M. Is K congruent to M? Yes, opposite angles are always equal in parallelograms, so always opposite angles are congruent. Next one, number 3, is JM, segment JM right here, congruent to KL? Yeah, opposite sides are equal. Actually, all the sides of a rhombus are equal. So always, all sides of a rhombus are equal. Number 4 is JK congruent to KL. So is this side congruent to this? Yes, always in a rhombus, all the sides are equal. Always, all sides congruent. And this one is JL congruent to KM. So it's talking about the diagonals now. Are those diagonals congruent? Well, diagonals bisect each other. Diagonals are congruent in a rectangle, but not necessarily in a rhombus, unless it's a square. Then the diagonals are congruent. So for number 5, sometimes the diagonals are congruent, only when it's a square. And then last but not least, number 6, angle JKM, so right here, is that equal to LKM, this angle right here? Well, we learned that the diagonals of a rhombus do bisect each other, so it would be always, or diagonals bisect the angles is what I meant. Diagonals bisect the angles of a rhombus. Okay, then for the next exercise, it says classify the quadrilateral, explain your reasoning. Okay, so when we classify shapes, we have to be careful because they can have multiple classifications. So for example, a square is also a rhombus and a rectangle and a parallelogram and a quadrilateral. So what we're essentially doing is we're going down to the most specific and then also naming everything above that as well. So to classify the quadrilateral, so they are all quadrilaterals, so we can start there. That would be the most broad classification. They're all quadrilaterals. Then for specifically number 7, it shows all the sides are congruent. All the angles are congruent like that. So yeah, this would be a square. But in addition to that, it is also a rhombus, a rectangle, and a parallelogram. So square is also all the things above it. So square is also a parallelogram, a rhombus, and a rectangle. So it's all of these things because it has the characteristics of all of them. Number 8. It's hard to see because it's black and white, but it shows these two sides are equal and this is equal to this. And it also shows a 90-degree angle here. So I would say this is a rectangle. But in addition to that, just looking at the family tree, a rectangle is also a parallelogram and a quadrilateral. So rectangle is also a parallelogram. And then this would be like the most specific. And here, same thing, 90-degree angles, opposite sides equal. So therefore it's a rectangle, but it's also a parallelogram and a quadrilateral. And then number 10, quadrilateral, because it has 4 sides, shows these opposite angles equal. The angles of a quadrilateral add up to 360, so this would have to be 40 degrees if you like subtracted that. And then from here, let's see, it shows these two sides are equal. These are also equal to that. It is a rhombus, most specifically. And then it's also a parallelogram. I know it's a parallelogram because opposite angles are equal, also opposite sides are equal. So yeah. Okay, then down here it talks about angle measure. So we're going to be filling in a bunch of these numbers using what we know. It says it's a rhombus, DEFG, and what we know about rhombuses is the diagonals are perpendicular, so it makes 90-degree angles here. And then we also know that the diagonals bisect the angles. The other thing we know is that opposite angles are equal, so we can use that fact as well. Okay, so looking at this, if it's a rhombus, angle 3 is 90 degrees here because the diagonals make 90-degree angles. Then here, the diagonals bisect the angles, so if this is 27 degrees, this is 27 degrees. The angles on the opposite side are the same measure because opposite angles are equal, so this would be 27, 27. Then to find number 5 and 6, we can actually use the triangles. So this triangle here has a 27-degree angle, a 90-degree angle, and then we can figure out the third. So 180 minus 90 minus 27 comes out to 63 degrees. So this would be 63 degrees, and this is 63 degrees. The diagonals bisect that angle, so whatever we get on one side has to be this angle on the other side. Okay. It will get easier because we just repeat the same process. So number 12, again, this angle right here has to be 90 degrees because the diagonals make 90-degree angles. If this is 48 degrees, this is 48 degrees. And then opposite over here, 48 degrees. And then for 2 and 3, we can use the triangle. So we can do 180 minus 48 minus 90. And it comes out to 42 degrees. So this has to be 42 degrees and 42 degrees. Okay, and then number 13, they just show one of the diagonals. Okay, so in a rhombus, all the sides are the same length. So what it makes is actually isosceles triangles. And in isosceles triangles, the two base angles are the same measure. So we could do 180 minus 106 to get 74. And then that has to be split evenly among those two angles. So 74 divided by 2 is 37. So this is 37, this is 37. And then this, in a rhombus, this bisects the angle, so this has to be 37 degrees and this has to be 37 degrees. And then opposite angles are equal, so this is 106 degrees. Okay, for the sake of our brains, we're going to skip 14. Down here, I want to add rectangle because rectangle comes up on the homework too. And I don't want to leave it out. Rectangle angles. So just kind of like make a little box down here. Okay, so for rectangle angles, we have a rectangle like this. And we'll have the diagonals. And so let's say they tell us this is a rectangle. They say this angle right here is 34 degrees. And they want you to find all the other angles. Say, what? How are we going to do this? Okay, so we use what we know about rectangles. I know that this is a 90-degree angle here. So if I do 90 minus 34, I will get this angle right here. So 90 minus 34 is 56. So this here, 56 degrees. I'm going to start there. Then, what else do I know about rectangles? I know that the diagonals are congruent and they bisect each other. So like all these lengths are the same measure. And it makes isosceles triangles. Isosceles triangles have the same base angles. So if this is 34, this is 34. And then also this triangle is going to be congruent to this one. So it'd be 34 here, 34 here. Ooh, I'm gonna use a pencil or something that's more precise. Then all these angles add up to 90. So if this is 34, this has to be, pen that writes better. If this is 34, then this is 56 here. This has to be 56. This has to be 56. Because all these angles make 90 degrees. Then the last step to find these angles, I can use the triangles. So I can do 180 minus 34 to find this angle here. And that comes out to 112. So I get 112. Vertical angles are equal, so this is 112. These two angles have to be supplementary since they make a straight line. So I can do 180 minus 112 to find this. 68. 68. And a square. Square is easy because everything's like equal in a square. So a square has its diagonals, right? In a square, all the side lengths are the same. All these segments are the same as each other. Technically, actually, let's see. So all these would be the same too. And then the square, because it's a rhombus, makes 90-degree angles here. So all this is 90. And then the diagonals bisect the 90-degree angle. So we'd have 45, 45, 45, 45, 45, 45. And it's all just perfect, perfect, perfect. Then on the back of this page, we're just going to do one problem, then we're done for real. Okay, on the back here, we're going to do number 21. Cross this out if you want to use this space, you can. Okay, so it says find the lengths of the diagonal of rectangle WXYZ. So you have a rectangle WXYZ. The diagonals here would be WY and XZ. It says WY is 6x minus 7 and XZ is 3x plus 2. In a rectangle, the diagonals are congruent, so therefore we can set these two equal to each other to find x. So we're going to just solve for x. 3x equals 9. X equals 3. So we found x equals 3, and then it asked for the lengths of the diagonals, so we need to plug that in. Wy is 6x minus 7, so that'll be 6 times 3 minus 7. So that'll be 11. And xz should come out to the same thing since they're equal. We get 11. xz equals 11. Okay. That's just all. So you have the rest of the time to get your homework done. So grab a laptop, log on, homework done. Hold on one second, Carla. Once you're